How's it, bro? Okay, let's tackle the first question. So they told us we're working with an arithmetic sequence. So we've got special formulas for an arithmetic sequence. And the first term says get the 36th term. So this formula is on your formula sheet, and I'm just going to recap what everything is inside of this formula. I also want to get my first difference and kind of glamify this thing, if you know what I mean, bro. So with our pattern, we can see that we are adding 7 to each term to get the next term. And this is the formula we're going to be using. It is on the formula sheet. So we've got a term value, first term, term number, and the constant first difference. Always a constant first difference with an arithmetic sequence. So our constant first difference is the 7 over here. Our first term is the 8. And our term number, we are getting the 36th term. So our term number is 36. So I'm going to set up a shell of brackets and chuck everything in. Okay, so we made the necessary replacements, and that is going straight in the calculator. There ain't no way I'm doing that in my head. Okay, so you just grab your calculator, type it in exactly how you see it there, press equals, and there's our glorious little answer. Just a small note here, if I'm working out the 36th term, it's no longer Tn, it's T36. So I'm going to go ahead and change that as well. And this question is only worth 2 marks. You get 1 mark for this line, the substitution, and 1 mark for this line, your answer. So you don't even have to write this, but it's great to have around. You know, I always write it, it helps me. Okay, and the next question asks us to calculate the sum of the first 36 terms. So let's grab my pattern quickly. And we're going to be utilizing the sum formula for an arithmetic sequence. It is on your formula sheet, and I'm just going to give you a quick reminder of what all the letters represent. So the Sn up front is the sum value. The 2 n's are the term number, as we've seen before, and A is our first term, and D is our constant first difference. So we have all of those. So if we want the sum of the first 36 terms, we're going to say S36. And now we're just going to pop everything in. N is 36, so I'm going to put that in place of N. A is 8, so I'm going to put 8 in A's place. And our difference is 7, so I put 7 in place of D over here. And because this question is only worth 2 marks, that thing is going straight in the calculator. No mental maths. You're wasting time if you do mental maths. So let's pop it in quickly. Okay, so I just typed it in my calculator as I see it there. I just press equals, and it pops out my answer over there. So the sum of the first 36 terms gives us 5,328. And it's only worth 2 marks, so you get 1 mark for your substitution and 1 mark for your answer. Question 1.1.3 is quite a big boy, 4 marks. So if it is given that this weird thing equals 786, determine the value of m. So m is sitting snug over there, but what I know is I can get the value of term 72, so I can basically work this out. So I'm going to go ahead and do that quickly, and we're going to do that with the formula we used in 1.1.1. Okay, so let's pop all our goodies into this formula and work out term 72. So I'm going to do the substitution quickly. And we are working out the 72nd term, so that goes in n's place. And then this goes straight in our calculator. And if we just type it in as we see it, press equals, we get 505. Okay, so we're starting to cook a little bit, bro. This term 72 is 505. So I'm going to grab this thing and replace term 72 with 505, because that's what it actually is. So you can see I've made the necessary replacement. Term 72 has been changed to 505. Now I want to isolate this thing so I can find out the value of it and work it out. So to isolate it, aka get it on its own, I want to move this 505 over to the side and it will become a negative. Okay, and then let's go ahead and work that out quickly. That's going to go straight in the calculator. Okay, so after we pop that in and we press equals, we get 281. Now what I'm going to do is I'm going to find out what term has this value, and that will allow me to work this m out. So we're going to use the same formula from earlier, and now we know the term value is 281. So I'm going to chuck 281 in there, and I'm going to work out n. Okay, so we sub everything in there. Remember our first term was 8. Our term number we don't know, that's what we're looking for, so we leave him behind. And our constant difference was 7 from the pattern. So now I'm going to take this 8 over, and 281 minus 8 will give me 273. And now I want to get rid of the 7 so that I can get n on its own. So I'm going to divide both sides of the equation by 7 to accomplish that. And then let's rely on our trusty little calculator to help us out with this. Over here, these 7s will cancel and we'll just be left with n minus 1. Then last thing, to get n on its own, take the 1 over, it becomes plus 1, so I know that n is 40. So now we're going to use a little bit of logic. So this is the 40th term. So 72 minus something must give me 40. I'm going to formulate that in an equation here. And then to solve that equation, I'll take this m over to that side, so it becomes positive. And I'll take the 40 over to this side, and it'll become minus 40. And we arrive at the final answer of 32 for m. And lastly, just to check where the marks are going, our first mark comes from the 505. Our second mark will come from the substitution here. Modeling this equation to find m will form the third mark, and the last mark comes from our final answer. Question 1.2, we've got a little frog hopping. And with every jump, he can only make 2/3 of the distance of his previous jump. Cool. So our frog is over there, he did 3 bounces. And if his first jump is 81 centimeters long, calculate his second jump. So what they're trying to ask you to do is don't work with pictures, work with numbers. This first question is trying to set you up to get the numbers. I'm going to do you one better. I'm going to get the first 3 terms so that I can have my pattern in nice numbers that I know how to work with. So what I'm going to do is take the length of the first jump, multiply that by the 2/3, and it should give me the length of his second jump. So if we pop that into the calculator, we get 54. So 54 is our second term. And just to make myself a bit more comfortable with the question, I'm going to go ahead and get the third term. I want to see a bit more of this pattern to understand it a bit better. So I just do the same procedure as before, multiply it by 2/3, pop that in the calculator, and I get 36. So now I can see my pattern for what it truly is. I've got the first 3 terms, and I can see I'm multiplying by 2/3 every time. If I'm multiplying by a number, it means I've got a geometric series. And then you're just going to get 1 mark for this question. The 1 mark will come from the 54 over there. And then 1.2.2, determine the length of his 9th jump. So I've got my pattern over here, and I've got to use the geometric general term formula. So I'm going to grab that thing and just give you a quick reminder of what everything is. So there's no need to remember this off by heart. It is on your formula sheet. We've got our term value that we've seen previously. We've got our first term also seen previously. The constant ratio is something new. Now to get the constant ratio, you say term 2 divided by term 1. If I say 54 divided by 81, it will give me 2/3. So you can also see it as what do I times by to get to the next term. And lastly, we have our term number sitting over there. So we want the 9th term. So that is the term number. So the term number will be 9. A is the first term, which is 81. And our ratio is the 2/3. So I'm going to chuck those 3 guys in here and it'll pop out the 9th term for me. So I'm going to do the substitution quickly. Okay, and then as you know, brackets bless our lives. So I always use brackets in place for my substitution. It always helps. Okay, if it's only worth 2 marks, this is going straight in the calculator. So I just type it in, press equals, and my little answer emerges. And then just another small thing, they ask for the length of his jump. Now, if we have a look, the jumps were in centimeters. So I've got to give a unit of centimeters, and at the same time, I'll just change this fraction into a decimal by pressing S to D. So it'll be 3,16 centimeters. And then the 2 marks for this question will come from your substitution and your final answer. And wrapping up question 1 with 1.2.3, the frog continues to jump in this way. He will be able to catch a trapped insect that is 230 centimeters away from his starting point. Will he be able to catch it? And we've got to show our calculations. So let's grab our pattern quickly. If we have a look at our pattern, we can see how the numbers are getting smaller. That means it's a converging pattern, which means I can use the sum to infinity to find out the total distance that the frog covered. And how you know it's converging is if the ratio is smaller than 1 or bigger than -1. So we're going to grab our sum to infinity formula, which is given on the formula sheet, so you don't have to remember it off by heart. So we've got the sum to infinity over there. We've got the constant ratio over there, and the ratio has to be in between 1 and -1 for you to use this formula. And we've got our first term on top there. So I'm going to pop all those in and see what happens. Okay, so I'll pop my first term in there, and I'll pop my ratio in there. And then this goes straight in the calculator. Let's see what it gives us. It gives us 243, and in this case it's centimeters, so our answer is 243 centimeters. And then we can make a comparison to the insect's distance away from the frog. So we can see the frog will get further than that, so he will make it to the insect with 13 centimeters to spare. So we've got to kind of answer this question. They say, will he be able to catch the trapped insect? So I've got to say, yes, he will. And it's also good to make a comparison to let your teachers know how you're thinking. So because this number was bigger than this number, that led me to the conclusion of yes. So just to check where the marks are coming from here, you're going to get 1 mark for your substitution, 1 mark for the sum to infinity, and 1 mark for your conclusion. Question 2 is still under the umbrella of patterns. Now we've got a combination of 2 patterns. We've got a quadratic sequence and an arithmetic sequence nested in this mess of numbers here. And the first question asks me to get the general term of the quadratic sequence. So I'm going to quickly separate the 2 patterns. Okay, so my quadratic pattern is in blue. And we can see it's the odd terms. So like the first term, the third term, the 5th term. So the odd term numbers of the quadratic pattern, which will make the arithmetic sequence the even terms, so like the 2nd term, the 4th term, the 6th term, so on and so forth. Now I only want the general term of the quadratic sequence. So for now, I'm going to ignore the arithmetic sequence and just work with the quadratic sequence. And now I want to start getting the differences underneath. So to get the differences, you say right minus left. So I'll say 0 minus 16, and that gives me minus 16. Okay, we're going to do that again for here. Right minus left, minus 12 minus 0 is just minus 12. And lastly, I'm going to do minus 20 minus minus 12. You mustn't forget the minus minus. and then these will turn into a positive, so it becomes minus 20 plus 12, which is minus 8. Okay, we're going to do that once again for our first differences. So we're going to say right minus left. So it's going to be minus 12 minus minus 16. And then these two minuses will make a plus. So I get minus 12 plus 4 plus 16, which will give me 4. Okay, and then the last one will be minus 8 minus minus 12. These two will turn into a positive, so it's minus 8 plus 12, which will give me positive 4 once again, just as I expected, because with a quadratic sequence, the second difference is always the same. It's constant. Alright, now I'm going to set up my 3 formulas. Now these 3 formulas are not on the formula sheet, so you have to know them off by heart. So the first formula at the bottom here is 2a equals this number. The formula in the middle is 3a plus b equals the first one here. And the third one is a plus b plus c equals the first one at the top here. Once that's out the way, I'll solve them from the bottom up. So I'm going to start with this one. I want to get a on its own, so I'm going to divide both sides by 2 to get rid of this 2. And that just gives me a equals 2. This 3a plus b equals minus 16. I'm going to grab that and sub a in. So you can see I've just changed a to 2, because that's what we got previously for a. 3 times 2 will give me 6, and then I'll take that 6 over to the side. And then 16 minus 6 gives me minus 22. Okay, now I'm going to focus on this last equation. So I'm going to grab it here and sub a, b, and c inside of that thing. So you can just see I've replaced a with 2, and I've replaced b with minus 22. And then a plus and a minus will give you a minus. So 2 minus 22 is negative 20, and then I take that over. And then 16 plus 20 will give you 36 for C. And then there's one last thing left to do. We chuck it all into our little quadratic formula, the standard form. So let's grab that quickly. So you don't have to write this. You can go straight to substitution. I'm going to put my A value in there. I'm going to put my B value in there. And I'm going to put my C value inside of there. And then my job is done for this question. And then lastly, let's just have a look where the marks are coming from here. So the 4 marks will come from the A, B, and C value, as well as the final answer, the general term. Next up, we need the general term of the arithmetic sequence. So let's go grab the arithmetic sequence that we sorted out earlier. Okay, so once we've got that, let's get our constant difference. It looks like I'm subtracting 4 every time, so that will be our constant difference. And now we can just grab our formula and get the general term. So we've seen this formula a lot in this past paper already. So let's grab him quickly. So I'm going to sub in my first term and my constant first difference of minus 4. And the term number I just leave behind, and then I simplify the whole thing. So let's sub into this formula quick. Okay, now that I've subbed in my first term and my constant difference, I'm going to distribute this negative 4 in. And then one last thing left to do, we just need to do the like terms here. 32 plus 4, that will give me 36. And then my job's done. There is the general term for the arithmetic sequence. So the 2 marks come from the substitution in this line, and your final answer in this line. (2.1.3) says the number pattern has 2 consecutive terms. Consecutive just means they're right next to each other. So like the 4th and the 5th term. That are equal in value. And we need to determine the position of the 2 terms. So what we've got to do is we've got to see where the patterns are equal. So I've got to grab the rules or the formulas for the patterns that we got from the previous two questions. And once I grab the formula, I'm going to make this one equal that one and then solve for n. Once I make them equal, I can see an n squared here. So that means this is a quadratic equation, which will mean I want to take these two things over and make it equal to 0. So let's go ahead and do that quickly. Just remember they become the opposite sign when you take them over. This one changes to plus 4n and this one changes to minus 36. Now I have the same number with opposite signs, so they will cancel. And I'm going to do the like terms over here. Minus 22 plus 4 is minus 18, and I'll glue the n on that. Now I'm seeing a common factor of 2 amongst both my terms, so I'm going to divide by 2 to get rid of it. And then there's a sneaky little common factor of n that I'm going to factorize out of this binomial. Once that's out the way, I equate each factor to 0 and solve separately. So that means my two answers will be n equals 0 or n equals 9. Okay, and we haven't finished with this question just yet. They want the position of the two terms. Now, it can't be 0 and 9 because they need to be consecutive terms, and there's no such thing as like the 0th term. So we're going to reject this answer, and we're only going to be working with 9. So now to put this into context, it's telling you the 9th term of each pattern is basically where this is happening. So this is quite tricky. It's a lot harder than what meets the eye. So you've got to kind of analyze a pattern within a pattern. So our original pattern was an overlapping pattern. It had two different patterns in it. So the first term of each pattern corresponds to term 1 and 2 of the original pattern. The second term of each pattern corresponds to 3 and 4 of the original pattern. The third terms of the quadratic and the arithmetic correspond to 5 and 6. So the 9th terms will correspond to 17 and 18. You can almost see a pattern where you times this number by 2 to get that one, or you times this number by 2 to get that one. This should be a 4, sorry. So now we can conclusively say determine the positions of the two terms. It's term 17 and term 18, and you write that like this. So we need to check where the marks are coming from here, so let's take a look at that quickly. So the 4 marks will come from equating the two equations, the correct factors over here, and then the correct answers with the rejection of 0, and the last mark comes from the position of the two terms. Question 2.2 presents us with sigma notation. So you've got to be able to break down sigma notation. So I'm going to quickly illustrate how to do that. So first thing you've got to know is that this symbol, it's a Greek letter called sigma, and it means get the sum. So they're asking you to get the sum of this pattern. This over here is your pattern rule. This one over here, you sub into the pattern rule to get your first term. And then the number of terms is the top one minus the bottom one plus 1. So we're going to apply that to this question here to solve it. So I'm going to get the first 3 terms so I can see what my pattern actually is. So I just bust out my calculator and I'm going to sub in this number into there, and it's going to pop out my first term. So instead of a k, I just put a 3 like this, and I press equals, and my first term is minus 54. To get the second term, you add 1 to the previous k value. So I'm going to overwrite that 3 to be a 4, and then it pops out my second term, which is 162. And to get the last term, I'm just going to change that 4 to a 5. Remember, you just keep adding 1 and you go through the pattern. And it gives me minus 486. Okay, so what I want to do with the first 3 terms is find out what type of pattern it is. So it looks like we're timesing by -3 over here. Normally the ratio is kind of hidden in this bracket here. So if we're timesing by a number, it's going to be a geometric sequence. Okay, and while we're here, we are going to need the number of terms, so we can pop it into our SN formula. So let's go get the number of terms by saying the top minus bottom plus 1. So that's going to be 9 minus 3 plus 1. And now I can kind of forget about sigma notation. I've extracted what I need from it, so it's kind of useless to me now. So I fall back into my normal procedure where I'm going to get the sum of a geometric pattern. So let's grab the sum formula for a geometric pattern. And I'm just going to give you a quick reminder of what everything is inside of that formula. So this formula is on the formula sheet, so you don't have to know it off by heart. So we've got the sum formula, or the sum value in front. We've got the first term over there. The constant ratio appears twice. Then we've got the number of terms as an exponent on R, and we've got a couple of minus ones there. So I'm going to chuck all this mumbo jumbo inside of here to work out the sum, because sigma is asking you please get the sum of this pattern. So let's chuck everything in quickly. Okay, so I've replaced A with the first term, which is minus 54. The ratio has been replaced with minus 3. The number of terms, we've got 7 terms from top minus bottom plus 1. So that goes over there and there. And also the ratio appears down here. Okay, so that's going straight in the calculator. Do not waste time doing mental maths. So if we pop it in and press equals, we get our answer to be quite a big negative number. So that's what the sum of the first 7 terms will be. Okay, so the marks come from the first term over here, the substitution, and the final answer, as well as the correct ratio being used. So if you had a ratio of minus 3, that's the 4th mark. And then we've officially finished this question. Okay, exciting news. If you own a white calculator, you can check these. Your white calculator has a sigma button over there. So you need to activate it by pressing shift and then this log button. And then you can literally just type in the rule. So I'm typing in the original question here. Okay. And that's going to be, you've just got to put an X instead of a K. And this lower number is 3 and the upper number is 9. And if I press equals, it takes a bit of a time, but check at that. Works out my answer for me. I can check my answer. What a dream life we live. In this question, we're going to be focusing on functions. More specifically the hyperbola, also known as hyperbolic functions. And the first question asks us to write down the equation of the asymptote of f. So this is f, that's the equation for this graph. And this equation can tell you a lot of things. I'm going to elaborate on that. Each little number here tells you something. So the top number tells you which 2 quadrants it's going to be in. If the top number is positive, it's in these 2 quadrants, which we can see happening over here. We can see it in those 2 quadrants. And then the P and the Q values form your horizontal asymptote as well as your vertical asymptote. So let's modify this to match our graph. Okay, so if we just pop in the numbers of our graph, we can see A is positive, reaffirming our quadrants. Over here, you must be careful. It's always the opposite sign. So if it's a +2 there, it's going to be a -2 here. Technically, you're supposed to make this equal to 0 and solve for x. But this is just a shortcut of doing that. And then y equals this number is our horizontal asymptote. So let's simplify that a little bit. And I like to also put them on my graph so I know more about my graph. So this horizontal asymptote is y equals 1. you can just write it anywhere close by as long as you associate it with the dotted line. And then the other vertical asymptote, this guy over here, the equation for him is x equals minus 2. And then you get 1 mark for each of those respective equations. Moving on to the next question, it wants us to determine the coordinates of A. If we have a look on our graph, A is over here. It's a very special point. It's where the graph cuts the x-axis, formerly known as your x-intercept. And to get the x-intercept, you make y equal 0. So I'm going to grab the equation of f of x, but there is a problem. I don't see y here. So what you've got to remember, f of x is a placeholder for y. So you change f of x to y, and we change that y to 0. Then I need to work on getting x on its own. So I'm going to take this 1 over, and it becomes negative 1. Once I've done that, I want to set myself up for cross multiplication. So I'm going to change this into a fraction by just putting it over 1. And then once that's done, we bring the bottoms up to the other side and we multiply going across, cross multiplication. So if I go ahead and multiply those, we're going to get 3 times 1, which is just 3. And then we're going to get minus 1 with this in a bracket next to it, like so. And then from there, 3 times 1 is just 3. And if I distribute this minus 1, I get negative x and negative 2. And then I take that negative 2 over to the other side. And when I do that, it becomes plus 2. So 3 plus 2 will give us 5. And then I divide both sides by negative 1, leaving me with x equals negative 5. Now we're not quite done. We need to still give the full coordinates of A, so I need to write that down. And the x value for A is negative 5, as we can see there. And the y value for A is 0, and we can even see that graphically here. It's got a y value of 0. And the negative 5 makes perfect sense because it's on the left of negative 2. So we have the coordinates of A to be minus 5 and 0. And the marks come from making y equal to 0 and the coordinates of A. Okay, we're getting to know this hyperbola a little bit better. So we know A's value now. The next question asks us to determine the coordinates of B. B is over here. Also a very special point, where it's where the graph cuts the y-axis. So something very similar to the previous question. To get the y-intercept, I make x equals 0. So I'm going to do exactly that. I'm going to grab the equation of the graph and I'm going to make this x 0. So that's all that changes in this step. And then this thing goes straight on the calculator. And if we pop that in, press equals, it just gives us 5 over 2. But we're not quite done. We need the full coordinates of B. So I just write those down on the side here. And then we've officially got full marks. So the 2 marks come from making x 0 in this line and the coordinates of B. And I also like to put it on the graph for better understanding. Color coding your graphs is also a very powerful tool. It helps your brain recognize it a lot easier because there's a lot of lines going on over there. Question 3.4 wants us to do a couple of transformations. So they're going to take, well, there's a new graph G. And that graph G is formed by reflecting the old graph F over the y-axis and translating it 2 units upwards. Translating is a fancy way of saying I moved it 2 units upwards, or I shifted it 2 units upwards. And now we need to get the equation of G. So I'm going to start with the first transformation, which is a reflection over the y-axis. Now when I reflect over the y-axis, only one thing changes. X changes to negative x. So I'm going to do exactly that. I'm going to grab my old equation and I'm going to change x to negative x. So all that changed, x, negative x, done. That's the equation after it's been reflected over the y-axis. Now I'm going to deal with the second transformation, translating it 2 units upwards. So if you're translating up or down, the rule is you add or subtract to the q value. If I'm moving it up, I add it to the q value. So just remember the p value is the one that's like next to x, and the q value is the one on the outside here. So I'm just going to add 2 to this number, and I get 3. And then my job is done. That's g of x. That's the new graph after the transformations. So you get 1 mark for this reflection, and 1 mark for this reflection, and the new equation of the graph. So transformations are not too bad if you know your little rules and where P and Q is. And the last question in 3.5 asks for the equation of one of the axes of symmetry of G. Now be careful, G is the new graph, it's not the old graph. So I'm going to grab this graph and be working with this graph. Now to get the axes of symmetry, we need the point where the asymptotes meet. So I definitely know the horizontal asymptote here is +3. The vertical asymptotes will be a little bit trickier. I don't want to take any chances there, so I'm just going to make it equal 0. Once that's out the way, I'll take this x over, and then there is my vertical asymptotes. Now those two will give me a coordinate of 2 and 3. And now that I know the point where the asymptotes meet, I'm going to take that point, sub it into my axes of symmetry to get C. So to do that, the first one is x and the second one is y. So I change this y to a 3, as we can see here. And I change this x to a 2, as we can see here. And then I'm going to take this 2 over to get C on its own, giving us the final answer of C equals 1. Because this 2 becomes -2 when you move it over. So let's check where the marks come from here. So the 2 marks come from your substitution of the correct point as well as your final answer. Question 4 focuses on functions, and we are given 2 different types of functions. There is a parabola as well as a straight line, which are also known as linear functions. So we've been given a whole bunch of information pertaining to the sketch. So if I see numbers or any valuable information, I do want to put it on the sketch. So I see AB is 2 units long. So this line AB is 2 units long. And I also see that CD is 7 units long. So from C to D is 7 units long. The rest of the information tells us where our x-intercepts and y-intercepts are, as well as the turning point. And the first question says, show that P equals 3. P is sitting in the formula for h of x. Now this is all a little bit overwhelming, so to make it less overwhelming, I'm going to color code my graphs, and that's going to make my life like 10 times easier. And have a look at what a difference that makes. Right, so we've got to get P. Okay, that's going to be quite difficult. So we're actually going to have to work with the green graph, and let me show you step by step how this goes. Okay, so with a linear function, I can tell a couple of things from its standard form. So with this linear function, the number on the outside is the y-intercept. So I know what the y-intercept of this line is. It's b. So I know the coordinates of b are 0 and 5. Okay, so I chuck that on my graph. And then I know this line is 2 units long. So I just have to go 2 units down to get to A. So if I go 2 units down from 5, I'm going to get to 3. So now I know the coordinates of A are 0 and 3. And now there's one of 2 directions you can go. You can sub this coordinate into h of x, and it will give you P equals 3. Or if you know standard form for parabola, then this number at the end, the c value, or in this case the p value, represents the y-intercept. And I have the y-intercept, it's 3. So we can just conclude that p equals 3. Geez, I had to work very hard for 1 mark there. And the mark in this question, we don't get a mark for p equals 3 because they gave that to us. We only get a mark for showing how we got the coordinate of a, and we said 5 minus 2 to accomplish that. Okay, so we're getting to know these a little bit better. I'm going to replace p with 3 because that's what it actually is. And I like to have the equations of the graphs close by, so I don't have to keep going back to this information. I can kind of do it without looking at that now. Next up, they ask us to determine the coordinates of f. F is over here, and they told us earlier that it is the turning point of the parabola. So I'm going to use my turning point formula. Okay, to get the x value of my turning point, it's x equals negative b over 2a. A is the number in front of x squared, so it's minus 1. B is the number in front of x, so it's that 2. So let's pop those guys in this formula. And if we just work that out quickly, it gives us 1, because we get negative 2 over negative 2. And now we need to get the y value, so I'm going to take this x value and sub it into the equation of the parabola. So what that entails is you just change these x's to 1s, and then it's going to pop out an answer of 4. So now I know my turning point f has the coordinates of 1 and 4. And our 3 marks here will come from this guy, our substitution in there, our x value and our y value. Now, great news if you own a white calculator. So if you go to your white calculator and you go to mode 5 and 3, then you can type in the a, b and c value from your parabola. A is minus 1, b is 2, and c is 3. So you press equals, then you press equals again. Now there's your first x-intercept. So that 3 is c over here. If I press equals again, I get my other x-intercept. So that's this x-intercept over here. If I press equals again, it gives me the x value of my maximum, which is the x value of my turning point. And if I press equals again, it gives me the y value of my turning point. Brilliant little calculator trick. Next up, we are asked to determine the coordinates of C. C is over here. It's a very special point for the blue graph. It's an x-intercept. And to get an x-intercept, I'll make y equal to 0. So I'm going to do that quickly. Just remember h of x is a fancy placeholder for y, so I just change that to 0. Now I've got a quadratic equation on my hands. This negative is bothering me, so I'm going to divide every single term by negative 1 to get rid of it. Then we can just see a sign change happening with every term after that's done. Now I need to factorize this trinomial. So I'm going to look at the factors of 3 that will add or subtract to give me negative 2. 3 is a prime number, so it only has 2 factors, which are 3 and 1. Okay, and then I need to add or subtract those 2 factors to give me that negative 2 in the middle. So to get that negative 2, I can just say plus 1 minus 3, and that will give me the negative 2 in the middle. And from there we can make our 2 brackets, x plus 1 and x minus 3. And from there we equate each one to 0 and we get our 2 answers. So we get x equals negative 1 or x equals 3. Now I've got to decide which one of these actually belong to C, because the parabola has 2 x-intercepts. And we do it using its position on the Cartesian plane. I can see this one's on the left of the y-axis, which means it has to be a negative number. So that x-coordinate over there is the -1. This x-coordinate over here has to be the 3, so C will be 3 and 0. And the 3 marks here will be from equating to 0, the correct factors, as well as the correct answer. And now the last question from question 4 is our challenge round, 5 marks. We need to get the length of EC. EC is a perfectly vertical line, and how I know that is because they said EC is parallel to the y-axis in the original question. So that's a fancy way of saying EC is a perfectly vertical line. So it's very easy to get the length of a vertical line. You just take the y value on top minus the y value at the bottom, but that creates an obstacle. We don't have the y value on top. So now I want to get the coordinates of E to make this happen. So to get the coordinates of E, I need its x value. And its x value will take the same x value as C because that is a perfectly vertical line. And then once I've got the x value of 3, I just want to sub that in here to get the answer. But now there's another problem. I don't have m. So I need to go get m somehow. So it's going to be done through the gradient formula. We're going to get the gradient of this line, and that is the m. So to use the gradient formula, we need 2 points on the line. Currently, we've only got this point B. We've only got a half a point here, so that won't work. So I'm going to have to get this point D using the 7 units here. So if this is at x equals 3, I'll go 7 units over to get here, and D will be at 10 and 0. Okay, and then just be sure to leave behind some breadcrumbs, or basically show some working out to show how you got that value of D. Now I'm going to use the gradient formula with D and B to get this missing gradient value. Okay, so our gradient formula, y2 minus y1 over x2 minus x1, that is on your formula sheet. So I'm going to choose perhaps B to go in place of y2 and x1. So let's chuck him in. And then I'll put D's coordinate in y1 and x1's place. And then if you pop that in your calculator, it's just going to give you -1/2. And now we've got our missing gradient over there. It's -1/2. Okay, now I'm going to return back to the original mission. I'm going to put this 3 inside of this formula to get his y value. So I just replace x with 3. And then that goes straight in my calculator. Okay, so if we pop that in the calculator, it gives us 7/2. And then for the length of a vertical line, I take the top y value, which is on the green graph, 7/2, minus the bottom y value, which is on the blue graph, which is 0. And then that pops out my length to be 7/2 units, or if you want to see it as a decimal, it is 3.5 units. Okay, to close up this behemoth of a question, let's have a look where the marks are going. Showing how you got the x value of D gets you your first mark. Substitution into the gradient formula gets you your second mark. The value of the actual gradient gets you the third mark. The fourth mark comes from substituting 3 into your equation, and the last mark comes from the final answer, 7/2 units. Question 5 focuses on inverse functions, and more specifically, it's the inverse of a parabola. because I'm seeing x squared, so I've identified this function as a parabola. And the first question asks us to determine the equation of f minus 1. It's a fancy way of saying get the equation of your inverse. And to get the equation of the inverse, you've got to remember these two steps. So first what you're going to do is you're going to swap x and y, and then we're going to get y on its own. So let's grab our formula. This f of x is a placeholder for y, so I'm going to change it to y. And now I'm going to swap the positions of x and y. And now I'm going to focus on getting y on its own. So I'm going to get rid of this 3 first by dividing both sides by 3. And our job is almost done. We just need to get rid of this square now. So I'm going to square root both sides. Also, I'm going to switch sides so that I have y on the left and x on the right. And also, when you square root, don't forget the plus minus in front of the square root. Okay, and then we are almost there. Now, with the original parabola, there's been a restriction to the domain over here, where x is greater than 0. It's kind of like saying where x is positive. So it stands to reason that our y value needs to be positive in the inverse. So we reject the negative one and just work with the positive one. And our final answer will look something like this. So we just work with the plus. We don't need to put the plus here because it's implied. And let's have a look where the marks are coming from over here. So the marks will come from swapping x and y in this line, getting the plus minus version of the root, and then selecting the correct root based on the restriction to your domain. 5.2 asks us to draw both the quadratic function f and its inverse, showing the intercepts with the axes as well as 2 points on each graph. So I'm going to start out with f. That's much easier to draw than this thing. So let's grab f's equation quickly. As we know, this thing is going to be a parabola because it's got x squared in it. So let's analyze it a little bit. So if we remember back to standard form of a parabola, these numbers are telling us something. So I'm going to modify this to match that graph. Let's do that quickly. So if you don't have numbers after this, we assume that they're 0. So it's like 0x plus 0. So now I know a is positive, so it's definitely going to be a happy face. And I know my y-intercept is 0 and 0. So I think let's just work out our x-intercept. Just a quick reminder of how to do that. To work out your x-intercept, you make y equals 0 and solve for x. So f of x is a placeholder for y. So I'm going to change this to 0 and work out x. Now I divide both sides by 3. 0 divided by 3 will just be 0. And this 3 kind of just disappears in that process. And then I'm going to square root both sides and I just get x equals 0. So the x-intercept is actually the same as the y-intercept. It's both the same point. I also need one other point on the graph because I've only got 1 point as it stands and they want 2 points. So I'm just going to choose a random number. The easiest one to choose is 1. So I'm going to sub in x equals 1 over here. Okay, so if I chuck 1 into x's place, 1 squared is just 1. And then 1 times 3 will just give me 3. So now I know the other point is 1 and 3. So now I've got enough information to get my sketch going. So I'll leave this working out here for my teacher to see how I got this point. And let's get a little Cartesian plane going over here. Once our Cartesian plane is up, we just plot these 2 points. And now we can go ahead and draw our parabola. But remember, we also have a restriction to the domain in place. So it's where x is greater than 0. So where x is 0 is over here. So they only want the part of the graph that's greater than 0, the one on the right hand side of the y-axis. So we've got to get rid of this portion of the graph. And once that's done, we've successfully drawn f of x. Now that we've got f of x out the way, we're going to turn our attention to the inverse, f of minus 1 of x. Now let's go grab his equation from the question earlier quickly. Okay, now this thing is hard to draw. I don't know what that function is or how to draw it. So it's much easier to kind of ignore this and work with this. So what you do over here is you swap x and y, and then you plot those points. So I'm going to do that manually on the side here. You swap the x and y values. So if I change those two, it doesn't change this coordinate. But this y value becomes the x value, and this x value becomes the y value. So you can just see I've swapped the position of those two. Now I'm going to plot these 2 points. And then I'm going to draw a sideways parabola that goes through those 2 points. And now I've successfully drawn both graphs. Here's f, and here's the inverse, f to the minus 1. And I did show the intercepts with the axes. These things only have one intercept with the axes. I showed it by writing 0 there. And the coordinates of 2 points on each graph, 1 point, 2 points, 1 point, 2 points. So I do have 2 points on each graph. So let's have a look where the marks are coming from. Okay, so one mark comes from the correct shape for f, another mark comes from the correct shape for the inverse, and then you get 1 mark for both points on f, and then you get 1 mark for both points on the inverse, this point and that point. And it is better to kind of write the full coordinates. It does help your brain see it better, as well as your teachers can mark it more easily. So instead of putting 0, just put the full coordinate of 0 and 0, and then we're officially done with this question. And the last question, 5.3, asks us to determine the values of x for which the original graph f of x is equal to the inverse. So what I'm going to do is replace f of x with its actual equation. And I'm going to replace f minus 1 of x with its actual equation and then solve for x. Once I have that set up and I analyze this, the first thing that's sticking out to me is the square root. So I'm going to get rid of that square root first by squaring both sides. Okay, so if I square this side, all that happens is the root cancels out with the square, and we just left with what's under the root. And then on the left hand side, I've just written it here to help make my life easier in a sense. So 3 times 3 will give me 9, and x squared times x squared will give me x to the power of 4. Once that is out the way, this 3 is bugging me. I don't like fractions, so I immediately want to get rid of it. So I'm going to times both sides of the equation by 3. 3 times 9 will give me 27. The x to the power of 4 does not change. And then this 3 cancels with this 3, leaving me with just x. Now, goodness gracious me, this is a quartic equation. So I'm going to take this x over. And now I can smell the common factor of x between these two terms. So I'm going to take it out. Okay, and then what you really want to do is treat this like a quadratic equation. So you're going to work with your factors separately now, because it's factorized and equals 0. So here's factor 1, and here's factor 2. And then I grab each factor and make them equal to 0. So there's my first answer, x equals 0. Over here, I need to work on getting x on its own. So I'm going to do exactly that. So firstly, we're going to move this 1 over, and it becomes positive 1. Now I need to get rid of this 27. So I divide both sides by 27. And now I need to get rid of this cube, and how I do that is I cube root both sides. Okay, now the cube root will cancel with this cube, and we just left with x on the left. And this guy over here can go straight in the calculator, press equals, and I get 1/3. And now we've officially answered the question, determine the values for x for which these two equal. So here's my first value for x where they equal, and here's my second value for x where they equal. So let's quickly take a minute to analyze where the 4 marks are coming from. So the 4 marks come from making the graphs equal, and the second mark will come from squaring both sides. The third mark comes from your first answer of x, and the fourth mark comes from the second answer for x. And then we have officially wrapped up this question. In this video, we're going to be focusing on sketches within trigonometry. So first things first, you want to make sure the trig ratio is on its own. So sine, cos, or tan needs to be on its own, and it is over here. So I'm going to move on to step number 2 of the process. I'm going to draw a little cast diagram close by and decide what quadrant I'm working in. With the cast diagram, it needs to meet both conditions mentioned in the question. So over here we can see tan is positive. So I'm going to tick the 2 quadrants where tan is positive. A stands for all is positive, so it's over in the A quadrant, and T stands for tan is positive, so I'm going to tick those 2 quadrants. And now we look at the second condition. X is an element starting at 180, ending at 270. So from 180 to 270 is in this quadrant here. And then we work in the quadrant with 2 ticks. So I'm going to draw an expanded view of this quadrant. And when I draw the triangle, you must think of the bow tie on how to draw the triangle. The bow tie just tells you to draw the triangle like this and not like this. So let's go ahead and draw our triangle like that. And the angle x, you always start on the positive x-axis and you go anti-clockwise until you touch your hypotenuse. Then we always use the angle closest to the origin as our reference angle. And now I'm going to start filling in the sides of my triangle. So I look at my trig ratio here and I think of Sokotoa. Okay, we are working with tan in this question. So the one on top is the opposite and the one at the bottom is the adjacent. So opposite to my angle will be the 3. And adjacent to my angle will be the 4. But you've got to be a bit careful. Look where you are on the Cartesian plane. This is the negative x-axis, and you're going under, so that's the negative y-axis. So both of these need a negative in front of them. And once that's out the way, we are going to work out the missing side using Pythagoras. So we're going to say our hypotenuse squared equals. Now our hypotenuse, we give it the name of r. R is short for radius. So the radius squared will equal the other 2 sides squared, and you add them together. Pop that in the calculator and it will give you 25, and then you square root 25, and you've got 2 possible answers for r. You could either be +5 or it could either be -5. And the rule with these sketches is your hypotenuse can only be positive. You can never ever have a negative hypotenuse. So we're going to select the positive version of the radius. And then we chuck that on the sketch at the same time. And now we're finally actually ready to answer this question. So to get the value of sine x, I just use so with my sketch. So let's go ahead and do that. Okay, so the opposite is -3 and the hypotenuse is 5. So it's just -3/5, and then we've officially finished this question. So let's have a quick look at where these 3 marks are coming from. So we get 1 mark for our sketch, 1 mark for the correct value of the radius, and 1 mark for our answer for sine x. Moving on to 6.1.2, a small little double angle over here. We don't have 2x in our sketch, so we need to somehow transform this to something with only x and not 2x. So we're going to use the double angles to accomplish that. Very luckily, with our double angles, it is on the formula sheet, and we only have one double angle for sine of 2 theta, or in this case 2x. So we're going to transform that thing into this using the double angle identities. So let's go ahead and make that change. Now that we made that change, we're going to fill in sin x and fill in cos x using the sketch. We can even grab sin x from here because we've done that hard work before. So I like to set up the shell of brackets like this. And then I'm just going to pop sin x into this bracket, and I'm going to pop cos x into this bracket. So sin x is minus 3 over 5, so that's going to go in this bracket. Cos x will be adjacent over hypotenuse, so adjacent to the angle is minus 4, and the hypotenuse is 5, so in this bracket will be minus 4 over 5. And now we've just got to work out this without our calculator. So I'm going to do the two fractions first. I'm going to say top times top to get my new top, and bottom times bottom to get my new bottom. And this 2 minus 2 won't change at all. So negative 3 times negative 4 gives me that 12, and 5 times 5 gives me that 25. Now I'm going to multiply this negative 2 with this bracket, and I'm going to kind of do the same thing like top times top, bottom times bottom, but I'll convert this into a fraction first. So I'm going to change this to 2 over 1. And then top times top will give me 24, bottom times bottom will give me 25. And now I'm subtracting two fractions, or I can turn this into a fraction. So I'm going to get the LCD and then subtract them. So I change this to 2 over 1. And to get an LCD of 25, I'll need to multiply this 1 by 25, and whatever I do to the bottom, I need to do to the top. So 2 times 25 will give me that 50, 1 times 25 gives me that 25. So now I've got an LCD, so I'm going to like kind of morph them into one fraction, like so. And now I can simply minus the tops. 50 minus 24 will give me 26. So my final answer will be 26 over 25. And lastly, let's have a look at where the 3 marks are coming from. So your 3 marks will come from the expansion of sine 2x with the double angle formula, the substitution inside over there, and your final answer. So I normally kind of type this line into my calculator and go straight to the answer, because it's going to waste quite a lot of time doing this mental maths over here and doing it without a calculator. So if you know where the marks are being given, you can kind of skate around that. Question 6.1.3, I see a 90 minus. The alarm bells are ringing for co-ratios. So let's grab my co-ratios quickly. Co-ratios can also be referred to as co-functions. So I'm seeing cos of 90 minus x, which is this co-ratio here. So I'm going to change it to sine theta. And that square will just be glued on to the sine theta. And in this case, instead of a theta, it's just an x. Now we got sine x earlier, so I'm not even going to do that with my sketch. I'll just go back to my previous work. You see sine x, here we have it as minus 3 over 5. So I'll pop that into sine x's place with the square on the outside. And now I'm physically going to work this out. So if I square this, what I kind of imagine that makes my life easier is you write the bracket twice. Because when you square something, you're multiplying it by itself. And then I do my usual story, top times top, bottom times bottom. So that will give me 9 over 25, and then the minus 1 just stays behind. Okay, now same story as what we did here. You've got to get an LCD. So I'm going to turn this 1 into 1 over 1. and then times the top and bottom by 25. So it kind of morphs into this. 25 over 25. And then I kind of combine those into one fraction because I have an LCD. And then 9 minus 25 will give me negative 16. And we have arrived at the final answer. Let's have a look at where the 3 marks are coming from. So we get 1 mark for the correct use of our co-function or co-ratio. We get 1 mark for the correct substitution of sine x. And the last mark comes from our answer. So always check this answer by typing this into your calculator, just to make sure all your working out steps are okay. Question 6.2 is quite a big one, 7 marks. So we've got this massive trig expression that we need to simplify. I'm seeing a lot of co-ratios. You see the 90 plus here. I see reduction, the 180 minus. And then I see kind of weirder things over there that we've got to sort out. So we're going to tackle this one at a time. That negative 1 can stay because I can't really simplify that. So over here, I'm going to reduce. To reduce things, you need your cast diagram. So let's get that going quickly. Okay, with the cast diagram, this is in the 180 minus quadrant, which is this quadrant over here. And in that quadrant, only sine is positive. So that will imply that this cos will be negative there. So this just changes into negative cos theta. And then the sine of theta minus 90 is quite a tricky thing to deal with. So I'm going to focus on it on the side here to show you how we get, sort of how we change that thing. So I'm quite tempted to use the co-functions, but there's no co-function with theta minus 90. So this isn't even a co-function, it's a whole thing on its own. So firstly what we do is we remove a negative out of the angle, and that switches the order. Then it changes into 90 minus theta, and it's almost starting to look like a co-function. And then you put a 360 over here, and then that takes us into the 360 minus quadrant over there. And in that quadrant, only cos is positive, so sine will be negative. So this will change into negative sine with that angle glued onto it. And then I can go ahead and change the sine of 90 minus theta into cos theta using my co-functions. And you almost want to get to the stage where you kind of know this off by heart. You don't want to show this working out because it doesn't get any marks. So you just immediately want to change this to this. So I'm going to do that over here. And then that sorts out this little complicated thing. Now we direct our attention towards this. That's not normal. I can't reduce it. I don't see 180 plus, 180 minus, or 360 minus. So I'm just going to put a 360 there. I'm going to add 360 to it to normalize it. So if something's weird or it doesn't make sense like this, you add or subtract 360 to make it normal. Okay, now that we've sorted out that one, let's direct our attention towards that. That's a pretty stock standard co-function. So sine of 90 plus changes into cos theta. So this whole thing will change into cos theta. And then this 540 is not normal, so to make it normal, I'm going to subtract 360. And 540 minus 360 will just give me 180. Now I'm going to start simplifying everything I can over here. This minus 1 can stay behind. Negative cos theta times negative cos theta is positive cos squared theta. And then this guy at the bottom here, he's in the 360 minus quadrant. Cos is positive there, so this whole thing will just change into cos theta. I like to wrap these guys in brackets as well, so that it helps me remember I'm multiplying these things. Okay, this cos theta is simplified as far as possible, so he can stay behind. And this tan is in the 180 plus quadrant. In the 180 plus quadrant, tan is positive. So this will just change into tan squared of theta. Okay, now I'm starting to see trig identities. So I'm seeing a tan here, and this is almost an identity. So you've got to think back to the identities you learnt in grade 11. These are not on the formula sheet, so you've got to know them off by heart. So if I see a tan, I can change it into sine over cos. And bear in mind that works with squares too. So if you have tan squared, you can also change that to sine squared over cos squared. And I'm almost seeing this identity on top here. I've got minus 1 plus cos squared. And this one is 1 minus cos squared. So to enable me to use this identity, I'm going to remove a common factor of negative 1 from the top here. And then at the bottom, cos times cos is cos squared theta. And I'm going to change the tan squared theta into sine squared over cos squared using trig identities. Okay, so in the bracket over here, I'm going to change this 1 minus cos squared into sine squared theta using my identities. The minus just stays in front. And then at the bottom, I'm multiplying these two. So I'm going to change this into a fraction, cos squared theta over 1. And then the cos squareds will cancel over here. So at the bottom, I'm just left with sine squared theta. And then the sine squared thetas cancel. And I'm just left with minus 1 as my final answer. And that brings this behemoth of a question to a close. Let's have a look where our 7 marks are coming from. Okay, so our reduction over here gets us the first mark. Our co-function over there gets us our second mark. This co-function over here gets us our third mark. And then reducing that correctly gets us our fourth mark. Reducing this thing correctly gets us our fifth mark. The correct use of the identity here gets us our sixth mark, and our seventh mark comes from the final answer. Question 7, we have to deduce this compound angle over here. So this is a bit of a weird question. We're going to start by grabbing sine A plus B. Okay, now I need to use this above identity to deduce this. So how I do that is I'm going to use a co-ratio to turn this sine into a cos. So let's grab our co-functions or co-ratios. And we're going to be using this co-function, but we're going to be using it backwards. So we're going to change sine of this angle into cos of 90 minus that thing. And don't forget brackets when you do that. So we can see that sine of this angle just turned into cos of 90 minus that angle. Then I distribute this negative to the A and to the B. And once I've got that out the way, I'm ready to use this formula. So to wrap your head around how to use it, let me show you quickly. This 90 minus A is this angle over here. And then this B is that angle over there. And we can see they have a minus in between them. That's been compensated for. So now I'm going to expand it with this formula or this compound angle. So to expand it, it's cos of A. So our first angle is 90 minus A, so that goes in the cos. And then cos of B, that B goes into the cos, sine of A, sine of B. So I do sine of the first angle and sine of the second angle. And then I've got two little co-functions over there. So I'm going to change these two guys using my co-functions. So this one over here, cos of 90 minus A, is this one over here. So it will change into sine theta. but in this case it'll change into sine of a. And the sine of 90 minus a, we'll use this co-function over here, and it will change into a cos theta, or in this case a cos a. And then we have successfully answered what the question was asking. It says use identity to deduce this is equal to that. We showed that that is equal to that through using that identity or compound angle. And lastly, let's have a look at where the 3 marks are coming from. So the first mark comes from the use of the co-ratio. The second mark comes from the rearrangement. And the third mark comes from the expansion. You do not get a mark for the final answer because they gave you the final answer. 7.1.2 starts off with this word hence. Hence is very important in maths. It's very crucial that you know what that means. So to put it in layman's terms, hence means use your previous answer or use the previous question to help you with this question. So my eyes start looking up at the previous question when I see the word hence. So we're going to grab this formula that we used in the previous question, and we're going to use that somehow to help us with this. So now I want to kind of make this thing look like that thing so I can use it. So let's do that by taking this term over to that side. Okay, so now it's almost looking like this. I do see a small problem. The angles are not matching up. So I'm just going to swap the order of these two so they do match up. And bear in mind, the order of multiplication doesn't matter. 3 times 4 is 12. 4 times 3 is 12. So I can switch these without really changing anything. It's also good practice to have the bigger angle first so that you don't get a negative angle. So now that that switch has been made, we can see it's resembling this identity. So I'm going to change this side into this side by just saying 48 plus 15. And now I successfully dealt with that word hence by using my previous answer to help me with this question. Okay, so 48 plus 15 will give me 63. Now I'm going to start working on the general solution of this equation. So this over here, how I think about it is it kind of goes on the left. And then this angle over here forms your reference angle. And now I've got to find the quadrants where sine is positive. So let's get our little cast diagram and see which 2 quadrants those are. So sine is positive in quadrant 1 and quadrant 2. So I'm going to set up 2 general solutions. One of them is in quadrant 1. And the other one is in quadrant 2. So this angle over here goes on the left. And then in quadrant 1 you just use your reference angle on this side. And for quadrant 2 you have to say 180 minus my reference angle over here. And then because we are working with sine, we need to say plus k360 after each of these to form the general solutions. And then for each equation, I'll just solve for x. So let's focus on quadrant 1's general solution first. I'm going to take this 50 over. And then it turns into minus 50. 63 minus 50 is 13. And then lastly, I just need to get rid of this 2 in front of x. So I'm going to divide everything by 2, including this k360. So these 2's cancel with each other, leaving me with just x. 13 divided by 2 is 6.5. And 360 divided by 2 will just give me 180, and the k stays there. And then just to wrap up this general solution, we've got to do a semicolon with k as an element of integers over here. And then we're officially done with quadrant 1. So we're going to rinse and repeat that procedure for quadrant 2. 180 minus 63 is 117. And then I take this 50 over and it becomes minus 50. Okay, try your best to avoid doing mental maths. So just pop that in the calculator, press equals, and you get 67. And the last thing I need to do is get rid of this 2. So I'm going to divide all the terms by 2 here. And after I do that, I get my second general solution. Remember to slap on that k is an element of integers at the end there. And then we are officially done with this question. So let's see where our 4 marks are coming from. Okay, these are quite hard fought marks. The use of our compound angle identity gets us our first mark. Both separate solutions get us our second mark. And then the third and fourth mark comes from each general formula. Question 7.2 gives us a trig expression. And we've been asked to simplify that trig expression to a single trigonometric ratio. So they just want to see a single cos in your answer, or a single tan in your answer, something to that effect. So I'm kind of seeing double angles here, not quite, but kind of, but I can manipulate it so that they are double angles. So let's have a look at our double angles and let's try and make these two things look like them. So on the top, this 4 sin x cos x, I'm almost seeing this, but the 2 is a 4, so that's a problem. So how we overcome that is we break the 4 up into 2 times 2, and we write it like so. So you just say 2 times 2 will give you that 4. So nothing has really changed. I've just expanded upon it a bit. And then at the bottom, I almost see this thing, but it's in the wrong order. To get it in the right order, I remove a negative as a common factor, and that will change the order of the bottom. So just to elaborate on change the order, you see how the 1 was second here, now it's first, and then the 2 sin squared x was first, and now it's second after I remove that negative as a common factor. So now I can actually apply my identities, so let's go ahead and do that. Okay, so we are getting somewhere. Bear in mind that 2 just stays in front here, and that minus just stays in front here. And you can see I've changed the respective ones with their double angle formulas. Now I'm seeing sine over cos. That's an identity. So let's grab that identity quickly. So sine over cos will give me tan. And if it's sine 2x over cos 2x, it'll give me tan 2x. It does work if your angle is 2x or 3x. It works so long as all the angles are the same. So that little pink box over there is going to change to tan 2x. And then 2 divided by negative 1 is just minus 2. So we're left with our final answer of minus 2 tan 2x. And I've successfully done what they asked, a single trig ratio. You can see there's only one trig ratio here. There's only tan in my answer. And the 3 marks will come from using your double angles in these 2 steps. That gets you the first and second mark. And the last mark comes from tan, well, your final answer, minus 2 tan 2x. And then 7.2.2 asks, for which values of x in this interval will the above expression be undefined? So for something to be undefined, it's when you're dividing by 0. So if you try do that on your calculator freaks out and gives you this little math error. So we're going to apply that logic to this question. We want the denominator of this expression to be 0 so that we get undefined stuff. So if we look at the denominator, it's this thing over here, but I've got a much simpler form of it down here. So I'd rather work with this than this. So I'm going to grab this thing and make it equal to 0 and then solve for x. Okay, I want to get rid of this negative by dividing both sides by negative 1, and it basically just disappears. Okay, now I'm going to do the QRS method. So I want to get my reference angle. How I do that is I say shift cos of this number, 0. So I'm just going to pop that into my calculator, and it gives me 90 as my reference angle. And now I'm quickly going to do a little cast diagram to decide what two quadrants I'm working in. So cos is 0. It's a bit of a weird case. In a case like that, you can choose either both the positive quadrants for cos or both the negative quadrants for cos. They both lead you to the same answer. In my opinion, it's much easier to work with the positive quadrants, so quadrant 1 and 4. And then how I start these off is this angle here goes on the left hand side of the equal sign. And then if I'm in quadrant 1, it's just the reference angle. So we'll just say 2x equals 90. And then because we're working with cos, we have to slap on a plus k 360. And then quadrant 4 is the 360 minus quadrant. So I just need to say 360 minus my reference angle plus k 360 for quadrant 4. Okay, now I'm going to solve for x with each respective equation. This one's quite nice and easy. I just divide everything by 2 and then I get x by itself. And that just leaves me with 45 plus k 180. I don't need to say k is an element of integers here because we're going to get answers in an interval. So you only need k as an element of integers when they ask for general solutions. 360 minus 90 will give me 270. And then to get x on its own, I just divide everything by 2 yet again. And now I can start working on getting my solutions within this interval. So what I'm going to do is basically I'm going to test out different values of k. I always start with 0 for k. So if k was 0 here, 0 times 180 would just be 0, and I'd get a solution of 45, which does lie in this interval. So that is one of my solutions, x equals 45 degrees. You can also test it with your calculator like this. You can pretty much retype this into your calculator, and instead of k, you've got an open set of brackets like this, times 180. Then if you chuck 0 in there, you can see it gives me that 45 I was referring to earlier. And then I normally go from 0 to 1. And then you can see that's too big. That's outside of this interval. And then I go back to -1. And that's too small. It's still outside of this interval. So I stop trying with this general solution. And now I move on to this general solution. Okay, so firstly with this one, I always start with k equals 0. Let's try that out first. Okay, that's too big for this interval here, so that's not working. So to go down, we'll have to go to -1 to make the angle smaller. And let's see what that pops out. -45, that fits snug inside of this region. So we found a second solution. And just to make ourselves comfortable, let's see if -2 will work. No, that's too small. That's outside of the solution. So we have found the values of x for where this thing will be undefined. Okay, so the 3 marks will come from grabbing the denominator and making it equal 0. And your 2 little answers. There are different various methods upon doing this. I like to go down the general solutions route so that it strengthens your skills with general solutions because they pop up a lot in matric papers. Okay, and the last question for question 7, we need to determine the value of this thing without even using a calculator. Goodness gracious me. Okay, but just remember, this is what we've been working on the whole time. We've been simplifying this expression and working with it the whole time. So we actually can simplify that. So check out this. Like, you see how this looks very similar to that question. And this thing can be simplified into -2 tan x. So I'm going to use that to my advantage. So I'm going to grab that quickly. So from the first question, we established that this whole mess simplifies into this pretty little thing. So now they're just changing the x's here to 15s. So I'm going to put 15 in all the x's and then work with this side, because it's a lot easier than working with this side. Okay, and then 2 times 15 is 30. And then to successfully do this without the calculator, I've got to use my special angles triangle in conjunction with TOA, and 30 will be my reference angle. So it's going to be opposite over adjacent, so 1 over root 3. So now negative 2 times 1 is just negative 2, and 1 times root 3 is just root 3, so there lies our final answer. So let's see where the 2 marks are coming from. So our first mark comes from changing everything to minus 2 tan of 30, and our second mark will come from the final answer, and we've officially waxed question 7. Question 8, we tackled the wild slungs known as trig functions. So we've been given a whole bunch of information here, and this doesn't look nice to my brain, so I'm going to color code this thing and it'll look a lot better. And check what a difference that makes. Okay, so first up we need to get the values of m and n. They are sitting snug inside the equations over here. So let's start with the cos x and get the m. So I'm going to analyze the cos x and I'm going to see how it's transformed from the original graph. In order to do that, you need to know what the original graph looks like. This is a must know. You must know this off by heart. So cos x has like a wavy shape, and we always use this point as our reference point. Cos x should start on 0 and 1. So cos x should start there, but now it's starting there. And this m over here is responsible for moving the graph up and down. So if you think about it, we just moved it down half a unit. So this m is minus a half. We must say minus because it moved down. If it moves up, we add it. Alright, now let's tackle the sine graph. Okay, so let's think of the original sine graph. So the original sine graph also has like a wavy shape, and then this is our focal point. It should start at 0 and 0, but this one doesn't start at 0 and 0. It starts at minus 30. So this graph has been moved 30 to the left. And if we look at the equation of that graph, this variable over here, if you're adding something to the angle, if it's inside the brackets, that moves the graph left or right. So we establish that this graph moved left 30 units, so it's got to be plus 30 over here. So if you're moving left, it's plus, and if you're moving right, it's minus. So all of this was like a sneaky little ploy to help you get the equations of the graphs, because they're not just asking for m and n, they're kind of asking you like complete the equations so that you have the proper equations for these graphs. And now that that's out the way, we can actually start answering questions. Now we have to write down the amplitude of f, which is our blue graph. So the amplitude is normally the number in front of x, and if you have a negative number there, you take the positive version of it. To give an example of that, if I had this cos graph, the amplitude would just be this number in front of cos, and you do not take the minus. So after that quick little sidetrack, the number in front of cos x is just a 1, so the amplitude of f is just 1. I'll even do you one better. I'll give you the amplitude of g. It's the number in front of sine. It's 1. The next question asks me to write down the amplitude of h. If they say write down, it means that there's no working out that needs to be shown. You simply just write down the answer. I'm going to do a bit of working out to explain how you do it, and then we'll just list the answer at the end. Okay, so h of x is a completely new function, and it's g of 2 of x. Okay, so let's go get that equation, let's have a look at it and see what to do. So h of x equals g of 2x simply gives you instructions to grab g and just replace your x's with 2x's. So that's exactly what I've done. I've taken g and I've changed x to 2x. And now to get the period of something, you've got to remember the period of the original graphs we were having a look at earlier. Really easy to remember, sine and cos. The original graph's period is 360, and then tan's period is 180. So those are stock standard. You've got to know those off by heart. So I'm going to take the original period and then divide it by the number in front of x to get my new period. So my original period is 360, divide that by the number in front of x, and we get the new period of this h of x to be 180. And of course, if they say write down, they kind of want you to do this all in your head and just give them that answer over there. I find I cope better with actually working it out like this, so I kind of ignore this advice. I'll still get the mark for my final answer here. So let's have a look quickly where all the marks are coming from here. They purely just going to be coming from the answers. So yeah, each answer just earns you 1 mark over here. But very hard fought marks. You need to know quite a lot of knowledge to actually get these marks. 8.4, we've got our challenge round. For which values of x will f of x times g of x be less than or equal to 0 in the interval from 0 to 240. So I'm only doing 0 to 240, so I'm going to ignore this side of the graph. So let's kind of get rid of it for now. So we're only going to be doing 0 to 240. Okay, now if I analyze this, f of x represents a y value. So to translate this in English, f of x is the y value of this blue graph. G of x is the y value of the green graph. And I want to multiply those together to give me a negative number, something smaller than 0. Or it could give me 0, something equal to 0. So there's only 2 possible cases where that can happen. And those 2 possible cases is if I say a positive times a negative, or a negative times a positive. That will give me a negative number. So I start all the way on the left of where I'm analyzing, and I ask myself, what are the y values here? The y value for the green graph is positive at 0.5, and the y value for the blue graph is positive at 0.5. And as I move along the graphs, things change over here. Now all of a sudden the blue graph has a negative y value, and the green graph has a positive y value. So it's working after 60. So I'm going to start formulating that over here. So this is kind of saying it starts happening at 60, and I'll put a square bracket because we have an equals to inequality over there. Okay, then it keeps working, but over here things change. Now all of a sudden the green graph has a negative y value, and the blue graph also has a negative y value. So it stops working over there. So this ends at 150. And then I'm going to quickly analyze if it ever happens again. It looks like both their y values are negative from that point onwards. So it won't ever work again. That's the only region where this is actually working. And you simply just get your 2 marks for writing that down. Bear in mind you can write it in a different notation like this. That is also acceptable. I found most people sort of understand this route, so I prefer to use that with these inequalities, but this is perfectly fine as well. And now the last question asks, to describe the transformations, which implies there's more than one, that the graph of G undergoes to transform to the graph of P, which has this equation. So I'm going to take more of an algebraic route here. You can use a graphical route as well. So what I want to do is change this to be x plus 90 so that I can use my co-ratios or co-functions. And to accomplish that, I'm going to need to add 60 to this angle to transform it into sine of x plus 90. And in terms of transformation, that means I translated the graph 60 degrees to the left. Remember, it's the opposite signs for left and right. Left is plus and right is minus. Okay, so now I've got a co-ratio. I've got sine of 90 plus theta. You can just change the order of this. It won't affect anything. 3 plus 4 is 7. 4 plus 3 is 7. So the order of addition does not matter. Now we're almost at the finish line. We just need to change this cos x to minus cos x. So if I times this by a negative, that implies that I did a reflection over the x-axis, because y will turn into negative y. It's quite complicated to see that, but if you see a sign change happening with everything in your equation, you can just remember that you're reflecting over the x-axis because y became negative y. So that's going to be our second reflection here, or our second transformation, reflection over the x-axis. And then lastly, the 2 marks will come from describing each transformation. So yeah, literally you have to write the words to describe the transformation. And that wraps up this paper.